The flicker comes without a sound. 1 second, your screen is alive. The next, it's a black mirror reflecting your own panic. The grid is gone. The solar charger you bought on a whim is a fragile circuit board, toasted by the same pulse that just silenced your city. But under the hood of your dead car sits a 60-pound beast of lead and acid, a 12-volt battery that didn't care about the pulse because it has no microchips to burn. Most people will stare at that battery and see a useless lump. You will see a raw, unregulated silent generator that can top off your phone 3 or 4 times and give you access to the only thing that matters now: offline maps, medical guides, the files you downloaded before the world went quiet. Subscribe so you never miss this. Stay for number 7. The reason charging your phone is only half the mission, and why the cell signal you're hoping for is already a ghost. Step 1. Assess the survivor. Pop the hood. Do not touch metal to metal yet. Just look and breathe. You need to know if the hunk of plastic and lead in front of you survived the pulse, or if you are wasting your time. Old vehicles, pre-2000s, diesels and beat-up trucks with mechanical fuel pumps, they have a fighting chance. Their batteries just sat there, dumb and durable, with no delicate engine control module to fry. A modern car with a push-button start and a computer screen in the dash is almost certainly a corpse. The pulse jumps the CAN bus and the ECU is bricked, but the battery itself might still hold a charge. Smell the air around the battery case. Rotten eggs means the internal plates shorted, and the electrolyte boiled off into hydrogen sulfide gas. That battery is dead and dangerous. If the case is cool, not swollen, not cracked, and there is no smell, you might have a survivor. Most people will grab jumper cables and start sparking terminals without ever checking. You will move slow, because the difference between a 12.6-volt life source and a plastic box of acid is a sniff and a glance. Step 2. The safe extraction. The battery is holding, now you remove it without a trip to the emergency room. Lead-acid batteries off-gas hydrogen. Tiny sparks from static on a polyester sleeve can ignite that invisible cloud and turn the battery into a plastic grenade. Work outside. No flame, no cigarette. Put on safety glasses if you have them. Wrap the wrench handle in electrical tape so you don't accidentally bridge the terminals with bare steel and weld yourself to the car. Disconnect the negative terminal first. Always. Black cable. The moment you break that connection, the chassis stops being a ground path and you cannot short the battery by accidentally touching the positive post in the car body. Then pull the positive. Red cable. Lift the battery straight out with both hands. It weighs 40 to 60 pounds. Do not tilt it. The sulfuric acid inside will pour out of the vent caps and eat through your jeans, your skin, your floor. Most people yank the positive first, touch the fender with the wrench, and get a face full of sparks and melted metal. You will follow the sequence. Negative off, positive off, lift clean. The power is now portable. Step 3. The $7 power tamer. Your voltage regulator. A car battery pushes 12 to 14 volts of raw DC. Your phone wants 5 volts. Most people's instinct is to grab a cheap inverter, turn 12 volts DC into 120 volts AC, then plug in a standard wall charger to convert it back down to 5 volts DC. That is a wasteful Rube Goldberg mess that burns precious energy as heat. You need one component: a bare DC to DC buck converter module. It costs $7 online. 2 wires in, 2 wires out. A tiny brass potentiometer on the board lets you dial the output to exactly 5.0 volts with a small screwdriver. No screen needed. No microchips that fry from an EMP if it was stored in a shielded bag. You wire the input side to alligator clips that bite the battery posts. You wire the output side to a female USB port salvaged from an old charger. Dial it once with a cheap analog multimeter if you have one, or trust the factory setting if you pre-tested it. The phone sees a clean, stable 5-volt current and begins to sip life from the lead beast. Most people will skip the regulator and try to hardwire straight to the battery. The phone will smoke once and never turn on again. The buck converter is the gatekeeper that turns raw power into a safe sip. Step 4. The inline fuse. The non-negotiable. A car battery is not a wall outlet. It is a chemical beast that can dump 800 cold cranking amps into a dead short without blinking. If your positive wire frays, if a connection wiggles loose and touches ground, that thin USB cable becomes a white-hot filament in half a second. It melts. It ignites. It destroys the phone, and possibly the hand holding it. The fix costs 50 cents and weighs less than a paperclip. An ATC blade fuse holder spliced directly into the positive wire between the battery clamp and the buck converter. Use a 5-amp fuse. Tiny, brown, or tan in color. Your phone pulls maybe 1 to 2 amps at 5 volts. A 5-amp fuse blows long before the wire catches fire, but well above your charging load. Most people skip the fuse because they want it to look clean and simple. They will feel the wire go limp and hot in their fingers and realize too late that they just turned their last power source into a car fire. You will splice the fuse holder with a crimp connector or a careful twist and tape. Test it once by briefly shorting the output before the phone goes on. The fuse pops. The battery survives. That tiny plastic blade is the difference between a controlled charge and a thermal event in your lab. Step 5. The terminal connection. Good, better, best. Good as alligator clips, the basic spring-loaded jaws you find on every cheap charger. They work, but they slip. A nudge of the table and the positive clip skates into the negative, and you get sparks and a dead short. Better is ring terminals. You crimp a copper ring to your positive and negative input wires. Then you bolt them directly to the battery posts with the same nuts that hold the car's main cables. Solid, vibration-proof, no accidental disconnects. Best is a salvaged cigarette lighter, plug, wired in reverse. If your vehicle's wiring harness survived the pulse or you are working pre-EMP, you build a male, 12-volt plug connected to your buck converter. You plug into the dead car's cigarette lighter socket. The car's own fuse circuit becomes your power port. No hood open, no clamps in the rain. You sit in the driver's seat with the phone charging silently off the car's own loom. Most people will pop the hood every time, letting heat out, letting moisture in, advertising to every passerby that they have power. You build the plug once, feed it through a cracked window, and charge invisible. The battery stays warm under the hood. You stay low. Step 6. Battery triage and longevity. You are sipping from a finite pool. The moment the voltage on that lead-acid battery drops below 12.2 volts, you are permanently damaging the plates. Sulfate crystals grow, capacity dies, your power source becomes a doorstop. You need a cheap analog multimeter with a needle, not a digital screen that the pulse already killed. Touch the probes to the terminals before you charge anything. 12.6 volts or higher is a full, healthy battery. 12.4 is good. 12.2 is the hard line where you stop. The phone gets one top off, maybe two, before the voltage sags to the danger zone. Most people will greedily charge every device in the house and wake up to a dead battery that cannot even power a ham radio or an LED panel later. You are not charging phones for entertainment. You are extracting offline survival files, maps, and medical references. Then you disconnect the buck converter, and you preserve the remaining capacity for a higher calling. A CB radio transmission, a water pump cycle, a single bright light when the dark becomes tactical. Treat the car battery like a blood bag in triage. Stop before it runs dry. The life it saves later might not need a USB port at all. Step 7. The nuclear signal surge. You charge the phone. The screen glows. The battery icon fills green. And then the instinct hits. You raise it to the sky, walking room to room, looking for bars that will never come. The pulse that killed the grid also killed the cell towers. The silent, unblinking equipment on every rooftop and hilltop is now just expensive scrap. Most people will burn their precious charge on hope scrolling, refreshing a dead signal until the phone dies again in their hands. You will not. The phone is no longer a phone. It is a tiny offline library. Before the event, you downloaded your region's offline Google Maps. You saved medical PDFs, survival manuals, mechanical guides, your family photos that keep morale tethered. You stored a frequency list for local ham repeaters that might still be alive on backup power. Now you open those files. You copy the critical information to paper while the screen is alive. Every minute the backlight glows is borrowed from a dying lead-acid battery that cannot be refilled. Charge the device, extract the data, transfer it to a notebook, and then power the phone down fully, not sleep mode, full shutdown. Preserve that battery for a future moment when a new signal might suddenly blink on. The phone is a retrieval tool, not a lifeline. The lifeline is what you write down.